Alright, so clean and check on the Trane. Looks like there's been some leaking going on, and it's interesting. Looks like the heat exchanger here is still good. Not that old, I guess. I am just observing these screws, see if these screws are rusted at all, because these older Tranes, secondary heat exchanger right there likes to crack right in this corner right here. So when you're doing these, make sure to keep an eye out for these two screws being rusty. And other than that, we're gonna do the burners, the drain trap. We got a PSC blower, which means that there is a capacitor somewhere. So burners, drain trap, capacitor, gas pressure, and combustion analysis. Alright, so we'll start with burners. Alright, 1/4-inch screw for the flame sensor. Out. Whoops. The flame sensor is starting to get grooved. That happens a lot with these Tranes. Oop. Our brass brush, scrub her off. Now, just because the flame sensor is starting to deteriorate doesn't necessarily mean that it needs to be replaced. I have had to use, with these Tranes specifically, actually, I've had to use flame sensors that have basically, you know, a portion of the rod has broken off, and I put it back and the thing still worked. As long as the flame is touching some part of the metal of this flame sensor, it's going to send microamps back to the board, and it will still continue to work. Also, as a side note on the igniter, Trane has two types of igniters. Has either a 120 volt igniter, and I believe the other one is either like 80 volts or 90 volts. Something like that. A 120 and a 90 volt igniter also. So just be aware that when you're replacing it, make sure that you get the right one. Alright. You definitely don't want to put an 80 or 90 volt igniter onto a system that is gonna feed 120 volts to the igniter. It will burn right up. So the flame sensor's clean. Our wire brush and just clean off the burners. These are obviously still in excellent condition. So clean them off and then put them right back in. That's a bit stiff. That's a little bit wide. I like for the crossover channel to be a bit more closed off. You can see also that the LP is starting to eat these burners up a little bit. Alright, drain trap. So, grab our pliers. I like the linesman. Linesman pliers, maybe not for this one. Oh yeah, it comes right off there. That pops off, and then this clamp as well. Pops right up. Take your flathead. Just pry the hoses up. Enough to be able to pop it up, and this one as well. And then we have one 5/16 screw. Comes out, and this thing pop right out. Get rid of this hose. Oop. A little bit of water there. Yep, and then there's with a capacitor right there. Alright, we're going to take this thing to the sink and clear out. Alright, so while we have the drain trap out, let's check out this capacitor here. Set your meter to microfarad. .6. The thing definitely needs to be changed. I'm surprised it hasn't failed yet. It wants 5 plus or minus 10%. So when it gets to 4.5, you should be recommending to the customer that they get it changed. So we'll bring it to the customer's attention and go get another capacitor. Okay, so have our 5 microfarad capacitor. Now it's not an oval capacitor, same as the old one, but looks like we can still force this thing in, which is, in my experience with metal, it's much easier to just force it back into place, you know. 2. Alright, after that we can go ahead and test gas pressure and combustion analysis. We have ignition. For a single stage propane. It says 13 for input gas pressure, and then supply pressure, 5 inches water column for natural gas, or 11 inches water column for propane. So we're looking for 11. And for adjusting the gas pressure, this has a little plug right here on the gas valve. We just unscrew it, set the plug off to the side, and turn it clockwise to increase the gas pressure and get it up to 9.7, 9.9. We're at 10. Also, keep an eye on the combustion analysis, the parts per million of carbon monoxide as you're increasing the gas pressure. Right now we're at 60 parts per million. We go up. Oh, looks like we're getting slight increase as we turn it, but I think 10 1/4 is as high as it's going. Okay, so we're still at 50 parts per million. So we're maxed out at 10 1/4. That means we do not have enough. Okay, so gas pressure was stuck at 10.25 regardless of how much we increased, regardless of how much we turned the screw, which means that we do not have enough input gas pressure to be able to adjust anymore. We've hit the max. So here's our propane tank, and right here is the regulator. You're going to want to turn the gas pressure up so that we can hit 11. Thread this out and then turn this counterclockwise, not too many turns. Counterclockwise to increase. We're going to go 1.5 turns and see how much that gets us. Okay, so 1.5 turns put us at 11.97. Now we can turn it back down to 11 inches of water column. Right there at 11, and would you look at that, the CO went down to where it's supposed to be. And that is the danger of having the wrong gas pressure, is having the CO high and sooting up the heat exchanger. So that is going to conclude the clean and check, or the maintenance, for this style of Trane furnace, and we'll see you all on the next one.